Welcome to qnawire.
So in this problem, we have been asked to calculate the lowest energy of this infinite square well, given 5 electrons in this square well. And the way we start is what is the equation that we have to use to calculate the energy, which is given in chapter 38, equation 13. So En is just n square, which is where n is the quantum number, or we can say that the state of the electron that it is in. So if n is equal to 1, so it is in the first state. If n is equal to 1, then it is in the first state. If n is equal to 2, then it is in the second state, the electron. And h square is the Planck's constant, m is the mass of the electron, and L is the length of the potential well, or width of the potential well. And this n can only take integer values which are 1, 2, and 3 to infinity. So in this case, since we have been given 5 electrons, and the only quantum numbers that we are considered here, we have to be considered with our n and ms, where ms is the spin of the electron, which can only take values 1/2 and -1/2. So in each of these states, let's say the first state, there can be 2 electrons following the Pauli's exclusion principle. One is spin up. Let's say that the spin up electron is like this, up arrow, and one is spin down. And then there can be no more than 2 electrons in the first state. Then we move on to the second state. There will be spin up and spin down. And that's it. The second state is filled. Now the last one electron will be in the third state. Either it can be spin up or spin down. Doesn't matter. So these 5 electrons. So the lowest energy will be. So the lowest energy will be, there will be 2 electrons in the first state, 2 electrons in the second state, and 1 electron in the third state. So E1 is, so we calculate E1, E2, and E3 using, using this formula. Okay, using this formula. So since everything is common except n for E1, E2, and E3, so let's say that we have 2, and n is 1 square. Then we have 2 electrons in the second state, and in that case n is 2, and there is 1 electron in the third state, and n is 3, and everything else is common, taken out. Let's say, sorry about that. 8m L square. So we just solve for this equation. So we have E is equal to 19 h square over 8 ml square. So that is the so that is the lowest energy of the state for 5 electrons in this infinite potential well. Okay, thank you.